इस वीडियो में हम लोग एटॉमिक मास यूनिट के बारे में जानेंगे। इसका बेसिक प्रिंसिपल क्या है उसके बारे में जानेंगे और कुछ उसका हिस्ट्री के बारे में जानेंगे। सो लेट्स बिगिन। In simple definition of atomic mass unit is it is unit of mass. Simple definition like kg, gram. Atomic mass unit is also a unit. हम लोग इसे यूज करते हैं एटॉमिक स्केल में जो जो सब कुछ है उसको मेजर करने के लिए हम लोग इस यूनिट को यूज करते हैं। तो ये कहाँ से आया उसके हिस्ट्री के बारे में जानेंगे, लेकिन उससे पहले चलिए उसका वैल्यूएशन करते हैं। तो बाय डेफिनेशन 1 AMU इक्वल टू 1/12 into mass of carbon 12 atom. So first we have to find out the mass of carbon 12 atom, then by dividing it by 12 we can find out the 1 AMU. Since we know 1 mole of carbon 12 has a mass of 12 gram. 1 mole equal to 6.023 into 10 to the 23 atoms. So total 6.023 into 10 to the 23 atoms के मास है 12 ग्राम। तो 1 एटम के मास कितने होगा? सिंपली 12 by 6.023 into 10 to the 23 ग्राम। That is the mass of 1 atom of carbon. कार्बन का एक ही एटम हम लेंगे तो उसका वेट इतना होगा। Another thing is we know carbon has 6 proton and 6 न्यूट्रॉन एंड उसके पास और एक 6 इलेक्ट्रॉन भी है, लेकिन इलेक्ट्रॉन का मास इज नेग्लिजिबल, सो वी डोंट टेक इट इनटू कंसीडरेशन। सो ओनली 6 प्रोटॉन एंड 6 न्यूट्रॉन ही है। सो टोटल 12 न्यूक्लियंस। सो टोटल 12 न्यूक्लियंस का मास है इतना 12 by 6.023 into 10 to the 23 ग्राम। सो अगर हम लोग 1 न्यूक्लियन का मास निकालेंगे तो ये होगा 12 by 6.023 into 10 to the 23 ग्राम, that is 1/12 into mass of 1 carbon atom, which is equal to 1 by 6.023 into 10 to the 23 gram, which is nearly equal to 1.66 into 10 to the power minus 24 gram. So here we determine the mass of 1 nucleon, but mass of proton and neutrons are little bit different. So 6 proton plus 6 neutron equal to mass of carbon, and mass of 1 nucleon equal to this. So we can say that it is the average mass of proton and neutron in nucleus. So 1 atomic mass unit is the average mass of proton and the neutron in a nucleus. Now in that scale, if you measure the rest mass of proton, which is different from the proton present in the nucleus, then we can find it that the rest mass of neutron equal to 1.008664904 AMU, and the rest mass of proton is 1.007276470 AMU, and the average mass of proton and neutron inside the nucleus equal to 1 AMU. This is all about the definition of atomic mass unit. चलिए अब उसके हिस्ट्री के बारे में थोड़ा पता लगाते हैं। क्यों कार्बन एटम ही हम लोग चुनते हैं, क्यों कार्बन एटम का ही रेफरेंस लिया गया है। देखिए ये एटम बहुत ही माइन्यूट है, ये बहुत स्मॉल है, उसे हम लोग अपने आंखों में नहीं देख सकते, तो we cannot measure it directly by our weighing machine. So we develop a concept called relative atomic mass. It is developed by first John Dalton and Thomas Thomson. And relative atomic weight, इसमें क्या होता है, यहाँ हम लोग सबसे लाइटेस्ट एलिमेंट दैट इज हाइड्रोजन को एज ए रेफरेंस लेते हैं, और विथ रेस्पेक्ट टू हाइड्रोजन दूसरा एक एलिमेंट लेट से ऑक्सीजन और कार्बन और समथिंग एल्स कितना गुना ज़्यादा भारी है ये हम लोग पता लगाते हैं। यानी कि हम लोग यहाँ पे हाइड्रोजन को जो सबसे लाइटेस्ट एलिमेंट है उसका मास को हम लोग 1 ले गए, 1.00, which is later developed to 1.008 gram, that is mass of 1 mole of hydrogen atom. So हम लोग 1 ले गए हाइड्रोजन का मास, और उसको हम लोग let we want to find out the mass of oxygen, then by taking a known amount of hydrogen and by reacting it with oxygen, what we get is water. We can weight water, we know the value of hydrogen, we know the weight of hydrogen, and we can measure the weight of water. So now by calculating all these we can find out the weight of oxygen. Suppose we take 4 gram hydrogen, means 2 mole of hydrogen gas. We take 4 gram of hydrogen and react it with oxygen. We don't know oxygen, we have to find out oxygen. We react it with oxygen, and what we get is 36 gram of water. So in that case we know what amount of hydrogen is reacted and what amount of water is formed, and by subtracting the weight of hydrogen from weight of water we can find out the weight of oxygen, which is equal to, here is 32 gram. So we also know the chemical formula of water. So in water we know 2 molecule of hydrogen combines with 1 molecule of oxygen to form water. So for 4 molecule of hydrogen it need 2 molecule of oxygen. So for 4 molecule of hydrogen we need 2 molecule of oxygen. That means here this is the molecular mass of oxygen that we get 32 gram. So when we divide 32 gram by 2, then we will find 16 gram, which is the atomic weight of oxygen. So generally chemists use this way to find out the mass of various element by taking a reference element, by reacting it with this and find out this. But later a good thought that hydrogen is not a good reference, so chemists move for oxygen. They determine the mass of oxygen by taking hydrogen, and by knowing the mass of oxygen they determine various other mass of the element. But उसके बाद क्या हुआ ना, hydrogen was no more a good reference to measure the atomic mass, because when we do chemical experiment we can see that oxygen is the most fundamental element that can combine with everyone. That is, all these periodic table can combine with oxygen to form a compound, but not with hydrogen. So many compounds are not cannot react with hydrogen, so we cannot determine their molecular mass or atomic mass. So we have to swap to oxygen as a reference to know the mass of other element. So what we did, we find out the mass of oxygen by taking hydrogen as a reference. Then we take oxygen as a reference mass to calculate the other mass. Similarly, as we see here, we can find out the mass of carbon by taking the mass of oxygen, which is equal by reacting it with oxygen with carbon. We can find out the mass of carbon. So here we know we take known amount of oxygen, we react it with carbon, and we found carbon dioxide which weight can be measured, and by subtracting the mass of oxygen from the mass of carbon dioxide we can find out the mass of carbon. Oxygen was a good reference to measure the atomic weight till 1927 or 1956. Oxygen was a good reference, but things become critical when the isotopes of oxygen were discovered. That is, oxygen has three isotopes, O17, O16 and O18. ये तीनों मास है ऑक्सीजन का, O16, O17 and O18. So elements also combines with different oxygen isotope to form the isotopic mass, but this is not going to do any harm for the chemist because the composition remains constant throughout the situation. The composition of oxygen, that is, although the three isotopes are present, but all these three combines with the target element to give a compound in which also these three also can present. So this is not create a big problem for chemist, but physicists face some problem here because they take mass of oxygen when there is three mass of oxygen, 16, 17 and 18. So it made some problem to them because their measurement went wrong. So what they do, they search for an element which isotope which is isotopically pure. That is, they found carbon 12. Although carbon 12 has another isotope, that is carbon 13, but it is very less in comparison to, its abundance is very low in comparison to carbon 12. And another reason is the mass of carbon 12 is exactly equal to 12 gram, and it has exactly 12 nucleons. So this is the main reason of taking carbon 12 as a mass, as a reference to find out the atomic mass unit.